Hello everyone, welcome again to my YouTube channel. So today I want to explain the AB problems from educational Codeforces rounds 153 rated for Div 2, which has finished right now, about 1 hour ago. So not a substring, it's problem A. It looks confusing at first, but you can grasp its idea a bit quickly. So pause the video and read this problem statement, and then I will start explaining. So overall, this bracket sequences call it regular if we can use it for calculating something, otherwise it's not. The main idea of this part is this. So we need to find this regular this brackets of length 2n such that s is not part of it. So what we have to do, if it's not possible, we have to print no. So why it is impossible? We have to find it. So for example, is it possible to do it with this? Yes, it's possible. We can do this. This. It's 1, 2, 3, 4, 5, 6. It's 1, 2, 3, 4, 5, 6. It's 12 lengths. So is it possible to do with this? Yes, it's also possible. We can do this for this. So overall, when it's not possible, there is only one case when it's not possible. It's also given in the sample case to help us. It's no for this case, it's no. Otherwise, we can always make it. First, we try doing it by this. For example, we get sequence. First of all, we need to get sequence S. And then if sequence S is this, answer would be no, otherwise always yes. And then we try to make our answer would be we take n and to be the s length of this n s. So then what we have to do, we have to make this answer, and then answer would be, so let me take this eraser. So answer would be n times this thing, this brackets. So now we have to again check if s we have to check if s is part of our answer. Then we have to make new answer. Answer would be n times opening bracket and plus n times closing bracket. So that's it, and we would get our A as accepted. So first we need one string S, then long integer n equals s length of this s. Now if s equals this, then answer would be no, otherwise, as I mentioned before, it's always yes. So then what we have to do, we need to take one new string, and for integer I 0 till so rep is defined above. If you're confused, till n we add. At first it would be like this, and we add brackets. If s dot ans dot find s equals -1, if it's not found, and s is not part of ans, so we will print this ans and this line. Otherwise we will take ans as a new, and again from 0 to the n we add opening brackets, and then closing brackets. Now this would be absolutely answer. So this solution worked. We will submit our code for A. So it's accepted. Now we will move on to the problem B. So it was 60. So problem B. So it's a good math question. So some people might solve it with if else's, but I use pure math, so I want to explain my solution. So try reading this problem statement, and then I start explaining. So overall we have m is the number we need to make, and it should not exceed m or should not be lower than m. So we have value k, which can be used by any number of fancy coins, or a k number of this regular coins that we have, and it doesn't count when answer is given, and a1 is the number of coins that's worth one regular coin. So now first of all now let me make it bigger. So first of all we have this m and a k. We need to solve this problem with only a k and k, then we will add a1 to this problem. First of all we have we can take most of this ak by subtracting this from m. So we have this we can use ak times for free, not for free but without getting any fancy coins. So m minus k times this, we can multiply it by ak itself, but sometimes it exceeds m, so we will get minimum of ak and m over k. So I think this is easy to understand. We have these values, three values of the above we are using right here. So we will subtract k times minimum of ak and m over k to make sure that we used ak and k efficiently, and then after this we can subtract all we have only this and k. now we don't have to care about AK because we are done with this problem. Now we can subtract A1, we can do this same thing, M and A1, but the problem is that sometimes, for example, right here, if we use it there is 0 of them, so we can tell about this one. So but for this one we have AK is 1, so we'll 11 minus 3 is 8, so if we subtract 6 we have 2. So what does 2 mean? We can't use 3 now because it will exceed m, and this means we should use 2 ones, and answer is 1. Why? So the reason is when we left with 8 value, we don't subtract 6, we are subtracting 5. When we subtract 5, we can use one fancy coin that worth 3 points, and it would be much less fancy coins. So that's the biggest problem of this problem B. So if you could solve this problem, you were done with this problem. So what would we do? So we won't do this thing. So we have to take some subtract m of x, such x that m minus x is I'm talking about m that is already when we already subtracted this value. So this value should be 0. So if it and x x is at most A1. So how can we solve this problem? So we know that theory that k minus x divided by k mod is equal to 0. This is the math theory. So using this theory, we divided it to much less one. So we have this one, and what we can do. So if A1 is bigger than this mk, we will take new variable. First of all, right here to be 0 at first, and we will make it to be m divided by k, because if it's bigger, for example in this case 11, we left with 8, and 8 divided by 3 is 2, and 6 is bigger than 2, so this value would be to subtract, to call it easier. So this to subtract would be this value, because we should take most of it. So now we will subtract this mk from A1, and if it is not the case, we will do nothing, and this would be 0. Because if it's not bigger, what we can do? We can do nothing. So it just will leave it. Sorry, to subtract. So we also we need to add, because we had 8, and we subtracted 2, and we left with 6. So, and we have also this 4, so we can still get some values. So we can add to this also A1 divided by k times k, and in this case I mean this whole part of it. If you're using Python, this would be like this. For C++, it stays like this. So now we will have this subtracted version of m equals m minus 2 subtract. Now you might think that we are done with this problem. No, also we need to make our answer would be q divided by k plus, because no, not q, subtracted divided by k plus subtracted minus subtracted by divided by let me call this subter for short, divided by k times k. So why is this? Why this works? Because our when choosing these fancy coins, first we need to make the most of this value of the coins which have value of k, and then we can use coins that worth 1 for the others. So you might think now we are done. So not yet. So there are some cases, for example, after doing this operation, think that we have now value of I think that we have now value of this, for example, we have k of 5 after doing this first operation only with ak. Think that we left we have k equals 5 and m equals 4, m equals 3, and we have ai is and this 1. So in with our case, what would be the value? The value would be subtracted version would be 3 itself. We are not doing this because 3 plus 1, 4. 4 is not divisible by 5, but 3 also is not divisible by 5. So what we have to do? So we can change the subtracted, and instead we can call a new variable different version and call it diff for short. So what would be the value of diff? So it's m minus minimum of m and a1. So now our answer would be minimum of our first answer, and then our diff divided by k plus diff minus diff over k times k, like the other one. So it's pretty much the same. After this we can happily print our answer. And also new line. Now we will implement this code. So first we need these values m k a1 ak. Then we will input this a1 ak. After this we will subtract k times minimum of k times minimum of this m over k and ak, as we did in the discussion part. And after this we will have this to subtract, I call it to sub, if ai is bigger than m divided by k, mod this 2 sub would be mk, and a1 will subtract this from a1, otherwise 2 sub would be 0. So now we will add this a1 divided by k times k to our 2 sub. So our long subtracted version, let's call it sub for short. Subtracted version would be m minus 2 subtract, and our answer would be subtract divided by k plus subtract minus subtract subtract divided by k times k. So now we need to consider this part also, long diff equals to m minus minimum of m and a1. So answer would be minimum of answer first, and this diff minus diff over diff, or diff plus actually diff minus diff over k times k. So also we need to also I forgot to add some parts. Sometimes our answer would actually be done without any fancy coins. So in this cases our answer would go to some minus values. So let me show you with this our case. First of all, we need to print this. So you will see for some of them we will get actually -6, I think. So here we got -6, actually it was 0. So it's easy one. Answer was the maximum of answer and 0. So answer would be maximum of answer and 0. So now we are done. I think you understood how we did this. It's long, sorry. How we did solve this problem. This is pretty much good math problem. I'm happy if this was useful for you. So let me check this code. So it's wrong answer on test 2. What we forgot here, let me check. So m minus k times minimum of and ak a minus m a1. Also so we should move this diff to the higher part, and then we need to, I think, a1 should be minimum of a1 and m. So then I think this should work. So let me resubmit this. This problem is really hard to solve by explaining. So let me see the test case. 21st expected 1, found 2. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So this case is ruining our code. So it's 2 and it should be 1. So why is this so? A1 and 2 sub n minus 2 sub answer n sub divided by k plus k, our answer is minimum of it, first answer difference plus different plus if minus. So let me remove these ones. Diff. Oh, this difference divided by k actually it is. So typing error. So let me submit this. So it's accepted. Thank you everyone for your watching time. Goodbye and follow for more content.